Good morning, my students of MTE1501. This is the third video tutorial. The first one was about an introduction. If you missed it, you didn't miss too much, but the second one was official. It was tutorial 2, and it was about assignment 1. Now, this video tutorial is preparing you to do your assignment 2. The unique number for students registered for semester 1 is 702649, and the unique number for students registered for semester 2 is 775358. Now, the submission date is the 14th of June 2021 for all students. You will also see that some of you received a letter to say that you are early completers. So if you are an early completer, you would get another date. I posted it yesterday on your announcements, but don't you worry about that. For now, for everybody, this submission date is 14 June. We have 5 questions covering all the learning units. The total of the 5 questions are 50 marks, and assignment 2 counts 35% of your year mark. You will see that it is not a compulsory assignment, but in the past, I have seen that it is almost impossible to pass the module without this assignment. So I urge you to please complete this assignment and send it in to better your chances to pass this module. Question 1 accounts for 12 marks. And you will see that it is about the history, the views, and the uses of mathematics in various civilizations across the world. And the question asks you to complete the table below. Now, the instructions say in the first column, write down exactly what type of numeral system people used in that civilization, like base 12 numeral system with 6 symbols, or whatever the case may be. And in the second column, write down one of the uses of mathematics in the daily life of that civilization, like to measure their lands for agriculture. Now, I want to go through those that I put in the table. The first one is the African. Let's just talk a little bit about the African numeral system and how people used it. You will see there that the bones, you will remember those bones that were discovered, Lebombo bones. And I put a picture here for you. There were several notches, they made markings on those bones. And clearly this was something like a calculator for them. We don't know. If you count them, they are 11, 13, 17, and 19 on one of them. Are they prime numbers? And then you see that there are also, on the bottom, there's 3, 6, 4, 8, 10, 5. Is that doubling? We also think there could be some sort of multiplication. Who knows? It is difficult to say what they intended to do with those Lebombo bones. But there are also something like 29, 28, 29 markings on some of these bones. Was it for counting the lunar or the moon month? Was it for counting the days? Do we see evidence of any base of number system? Remember, those numbers that are on the picture there never appeared there. They didn't have numbers to write. They only made the notches. Can we say that they used a base 10 or a base 12 number system? Because they only counted 1, 2, 3, 4, 5, 6, 7, 8. We cannot tell whether there is a number system there, but definitely they had a use for this. So read in your books and see what the discussion is about this African way of using numbers that we have in the bones. Now, the second one was the Babylonian. You need to read paragraph 1.5.2 in your tutorial letter 501, that is your study guide, and you will see. Now, I just want to go through this with you. These are the symbols they used. It's little pictures. They did it in the early days with something like nails. You can see it's like a nail. When you look at number 1, it's a nail that they hit into something. So 1 nail, 2 nails, 3 nails, and then they made the pictures of those nails. Now, if you go down, you will see they go up to 10, and then they start adding the 1. For 11, it is that 10 symbol and the 1. And for the 20, it's 2 10 symbols and 1. And for the 30, it's 3 10 symbols and a 1, and so on. But in the end, the whole lot are in groups of 60. So please read paragraph 1.5.2 to make out what do we have here. Do we have a base 10 or do we have a base 60 number system? You will find the answer there in that paragraph. Now the Chinese, you need to read paragraph 1.5.6. Now they had these little stripes that they made. They made it by pen. 1 stripe, 2, 3, 4, up to 9. And then for a number like 846, they would put that 8 symbol first, and then the 4 symbol, see they turned it on its side, and then the 6 symbol. So what we can see there is that the 8 stands in a certain place. The 4 stands in a certain place, and the 6 stands in a certain place, which tells us there is something like a place value system. An 8, a 4, and a 6. But now, did they have a symbol for 0? It doesn't look like, because if you look at that number 2063, they just made a space there to say there's nothing there. But there was not a symbol for the 0. They just put the 2 and then a nothing, a space, and then the symbol for 6, and then the symbol for 3. So you can fill in your table using this information and reading paragraph 1.5.6. And remember, decimal. When they say in that paragraph, they used a decimal system. Deci means 10. So that gives you an indication of what type of base they used in their number system. Right, the other 3 are Egyptian, Indian, and Greek. Let's go to Egyptian. What they did was they used a little picture. The first one, they say it's a line. The second one, they folded the line into a loop. That was for 10. And then a rope for 100. And then what they called a flower for 1,000. And a finger for 10,000. And a tadpole for, that is a small, I think it's the small of a padaki or something. I don't know what the tadpole is. And then padafis. And then the million is a god. So they had symbols for things going in powers of 10, because 1 is 10 to the power of 0, then 10 is 10 to the power of 1, 100 is 10 to the power of 2, 1,000 is 10 to the power of 3, and that is what we also use today in our number, in our place values. We have a ones or a units, a tens, a hundreds, a thousands, and so on. So there's something that corresponds, but you will read that in paragraph 1.5.5. What was the base they used? Was it a base 10? Was it a base 60? Base 12? You can clearly see what it was. And were there place values? You will read that in paragraph 1.5.5. Now the Indian, very interesting, the Indian, they started, they put together many cultures' way of writing numbers. So you can see how it came historically from the top one, what they call the Brahmi, they wrote it like that. Then the Hindu people wrote their symbols like this. But you can clearly see that they always made a distinction between the first 5, you can say, of your left hand and the second 5 of your right hand. So there were definitely 10, but it was in 5s and 5s. They organized it in the 5 numbers that you get on your left hand and the 5 numbers you get on your right hand. It was definitely stimulated by the fingers of a hand. So you can see there's the Sanskrit and then the Western Arabic and then the Eastern Arabic way of writing it. So this is how it developed. But in the end, in the 15th century, you can see in the 11th century, it developed like that. In the 15th century and in the 16th century, we almost have something like we have today. It is just that 2 that doesn't look really like what we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then a little circle for the 10. So you will see that this is how the numerals developed. But we are not, a numeral is the symbol, but we are looking at what is behind that. How did they count things? Did they count in tens? Did they count in 60s? Did they calculate in tens or calculate in 60s? That is the number system. We are not looking so much at the digits than at the meaning behind those digits or numerals. So Hindu and Arabic are associated with Indian, and Hindu-Arabic numerals are what we use today. But you will read that in paragraph 1.5.7. Then the last one is the Greeks. Now the Greek corresponds to what you always used to get in school, like the Roman letters. The Greek used the letters of the alphabet to associate a number. So the alpha, beta, gamma, delta, epsilon, those are the numbers A, B, like our A, B, C, D. If you look at 1, it's alpha. And then beta, gamma, delta, epsilon, vowel is a symbol, a letter symbol that they don't use anymore. But zeta is there, eta, theta, iota, kappa, lambda, and so on. So they use if you see an A or an alpha, you know it's number 1. So they combined them to make up a number. But you have to read in that paragraph, what was the base? How was a number written? Was it written in a place value or was it not? Was it just a compilation of a lot of these letter symbols? Now, a very interesting thing that I want to show you, the original decimal symbols that we have were identified by the number of angles that the digit had. So a 1, they wrote like that. A 1 has 1 angle. The 2 has 2 angles. The 3 has 1 point. There where the dots are, those are the number of angles. So you can see that this is a very interesting discovery that people made. That look for example at the 8. If you look at the internal angles, 1, 2, 3, 1, 2, 3, and then the 2 external angles makes up 8 angles. This is just for interest's sake. One day when you are a teacher, you can say that to your learners and they will be very interested in that. They always like things like that. Okay, let's go to the next one. This was question 1. I think you will be able to answer that. And then question 2 is, it counts 8 marks. And question 2 is about something that we talked about last time also. And you can just refer back to the previous, but I also put the slides on here. This question is about the approach to teaching and how much learners are engaged in the lesson. Now, you will remember that we talked about this, the old way or the traditional way, the way that you and I probably were taught in school, and also the way that we teach in the modern mathematics way. Now, this teacher, Ms. Mabasu, is Tembile's grade 7 mathematics teacher, and this is what she does. She teaches the class steps of the algorithms. Algorithms means the method or the strategy, how you calculate. She teaches them the steps. Let us say, for example, of division. She teaches them the steps of division to perform the 4 operations, that is plus, minus, multiply, and divide. Add, subtract, multiply, and divide. The 4 operations on numbers correctly. Very important. She wants them to get the correct answers. She gives them quick tricks to get to the right answer in things like ratio and dividing fractions. She insists that learners listen, but they are not allowed to ask questions or to talk in class. She keeps a strict discipline in the class. It's very quiet in that class. She requires learners to learn and memorize formulae and rules out of their heads. They must remember it. She gets the best mathematics results in the circuit, but it showed that when learners go to high school, they struggle. And I can also tell you now that this is probably because they had to remember things without understanding it. And when there's anything new, they are not able to think for themselves, because actually she was thinking for them. She gave them the rules. And I think most of you that struggle today in mathematics, you had this type of teacher. She told you what to do, but when you come to a new situation, you cannot think for yourself. You can only think what Ms. Mabasu told you in your school, but you cannot apply it for yourself because you did not understand it at that time. That was the traditional way of teaching. In the last bullet, she controls tasks, investigations, projects, and all learners deliver almost the same work or the same type of quality. The thing is, she gives such clear instructions that learners do not have the freedom to think anything for themselves. You must do point 1, 2, 3, 4, 5. That's what you must do. You cannot do anything else. Let's now see, this is the scenario that we sketched. There's teacher. She tells them, divide a fraction by a fraction. This is what you do. She doesn't allow them to ask questions. In this one that I put on here, she said, divide 2/3 by a quarter. What are you doing? You say 2/3 times 4 times 1. You flip and multiply. And then you multiply the top one. 2 times 4 is 8, and 3 times 1 is 3. And you make sure that you put it in a mixed number. 8/3 is 2 2/3. You divide the 8 by the 3 to find the whole number, and the remainder goes on top of the fraction. That's what you do. Okay, now we look at Ms. Mabasu's teaching, and we say there are 2 main ways of teaching mathematics. The first one is the behaviorist teaching. And now you can think of Ms. Mabasu, and you will see under which one of these 2 does she fall. In behaviorist teaching, the teacher is the active one in the class. The learners are quiet and passive. The teacher dishes out knowledge, and learners receive it without a question. Teacher gives methods, rules, and steps. The learners follow the methods, rules, and steps. Teacher regards good scores as a sign that the learners have learned well. Only visible learner work counts as a proof of math understanding. So when anybody comes to her and say, are your learners understanding? She will say yes, because their marks are good. Okay, now the constructivist teaching is like this. The teacher creates the opportunity for learners to actively explore the ideas. The teacher explains and the learners ask questions until they understand. Teacher explains methods, rules, steps, and learners explore till it makes sense to them. Scores are not the main purpose, but how much sense something makes. Understanding mathematics means more than tests. There is thinking too. So I think I'm going to go to the previous one. If you look at this, learners will know exactly what to do when they divide a fraction by a fraction. When this teacher is teaching them, because she gives them a quick trick, flip and multiply, then you get the answer. But they do not know what this means. This description of Ms. Mabaso is typical of a certain approach to teaching. This is what your question says. A certain approach to teaching mathematics. With that in mind, complete the questions below. Label or classify the teaching approach. Now, this is an approach to teaching. So classify this. Say whether this is a behaviorist teaching or is it a constructivist teaching. The second one says, describe the level of learner engagement. How much are the learners engaged in this? Or what is their engagement? What are they doing? You cannot just say they are not engaged, because in the end you will see work in their books. But what is their level of engagement? How do they engage? What part of this class, we call it a discourse, the conversation going on in class, what part are they taking? Describe it. And then explain the advantages of this teaching approach. What is good about it? There's nothing in this world that is only bad. What is good about it? And what are the disadvantages of this teaching approach? Later, when you are a much more mature teacher, you will see there is a place in teaching to do this, to do this, that she is teaching them a method. There is a place for that. But you will tell me, is this really the best way of doing it? We are going over to question 3. Question 3 counts for 10 marks. To answer this question, you need to complete the table below and also study paragraphs 2.7 to 2.13 in your study guide. Most important here is that you understand what are behaviorism and constructivism, the one that we have just covered, that you understand what is inductive and deductive reasoning or thinking. We will do that in a minute. And that you understand what is instrumental and relational understanding. And also what is procedural and conceptual knowledge and elements of mathematics proficiency. So this is a very, very important, absolutely important part in your work. It is, I think it is in Learning Unit 2. Yeah, I think the paragraphs, because it says 2.7, 2.13. But this is a very important part in shaping your future as a mathematics teacher. What type of teacher are you going to be? What type of thinking will you see in your learners? What type of understanding will you create in your learners? And what type of knowledge will they have once you are done with them? And what proficiency, how able will they be? So when you see me teaching, you will see that I am doing in a certain way, and I'm doing it in the modern way, to role model to you how you can be a teacher one day, to make your learners, in my case, my students, understand completely what things are about. And not to make an assessment something to catch you out, to get bad marks or to see where you are wrong, but to make an assessment an opportunity of learning so that you develop through this assessment. And this is what I'm doing with you. I'm using this assessment to develop you, not to catch you out, to make you fail, but to make you, I set you up for success. And this is what we want to do in our learners. You will remember in your past that teachers set you up for failure. That is the absolute opposite that we need to do in this country. We have to set up our learners for success. So let's go into this question bit by bit. If we look back at that teacher, we take this example again of dividing a fraction by a fraction. How would a constructivist teacher, for example, explain a third divided by a third? It's a very difficult concept. And teacher Mabasu just said, just flip and multiply. That's what you must do. But the learners have no idea why. So I set this example up for you so that one day in your teaching, you may also use this very example to teach, to help your learners understand. In the left-hand side, I made an example of a third divided by 3, not by a third, by 3, by a whole number. So that is a fraction divided by a whole number. And if you look on top, there is what we call the algorithm. This is the way that you work it out. You say it is 1 over 3 divided by 3 over 1, which is 3. And then you say it equals 1/3 times 1/3, and it is a 9th. So if a behaviorist teacher will stop there, but a constructivist teacher will explain it by an example in the real life. So I made an example for you. There's a bottle. This bottle can take 900 milliliter of juice. So if you divide this bottle in thirds, the first third will be 300 milliliter, then 300 milliliter, and then 300 milliliter. A third of 900 milliliter juice is 300 milliliter. I divide the bottom 300 milliliter into 3 equal parts. That is your sum there on top. It is 1/3 divided by 3. 1/3 divided by 1, 2, 3 parts. And I take only that part. And that is 100 milliliter. So 100 milliliter is 1/9 of 900 milliliter. There is the 1/9. That is why a third divided by 3 gives me 1/9. So now we go over to what is 1/3 divided by 1/3 there. And there's the algorithm as the way Ms. Mabasu explained it. Just flip and multiply, and she gets 3 over 3, and it is 1. How on earth does this work? That when I divide it by 3, I get a 9th, and when I divide it by a third, I get 1. How do I understand this? Now, we have the same bottle. We divide it in thirds, that third, a third of this bottle. Now I'm going to divide that by third bottles, bottles that can take a third of this big bottle. So I divide a third of the juice, which is 300 milliliter, into thirds bottles. A third bottle of this takes 300 milliliter. So 1/3, 2/3, 3/3. I divide it by thirds. So it will fill up 1 whole bottle. That is why 1 whole bottle comes out of this. 1/3 divided by 1/3. You can keep this for future use.